A fast-moving object the size of Manhattan is hurtling towards our solar system.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
For months, astronomers around the world have been tracking 3I Atlas, the third confirmed interstellar object ever detected passing through our solar system. At first, it seemed like just another wandering interstellar comet, fast, unpredictable, and ancient. But everything changed when NASA confirmed that 3I Atlas suddenly reduced its speed by nearly 300%, an event that no natural celestial body should ever be capable of. And the moment the data came in, alarms went off across multiple space agencies. Labs were ordered into emergency analysis mode. Teams were woken up in the middle of the night. NASA quietly issued an internal high alert notice, and the world's most advanced telescopes turned their eyes toward this mysterious visitor. No one expected Atlas to behave like this. No one expected an interstellar comet to violate the laws of physics as we understand them. And no one expected the James Webb Space Telescope to uncover details that now have researchers deeply concerned. Not just about what Atlas is, but about what slowed it down. Ever since Oumuamua shocked scientists in 2017 and 2I/Borisov followed 2 years later, astronomers have known that interstellar wanderers occasionally pass close to our sun. But both of those objects behaved like objects that didn't care about us at all. They came, they passed, they left, obeying predictable gravitational mechanics. Atlas, however, is not following the same script. Its trajectory, its rotation, and now its sudden loss of speed suggests that something extraordinary and possibly catastrophic has happened to it. So what exactly caused 3I Atlas to slow down? Why has NASA placed multiple solar system monitoring stations on alert? And what has the James Webb Telescope seen that the public has not yet been told? To understand why this speed reduction is such a big deal, we need to look at what Atlas actually is. When it was first discovered, Atlas appeared similar to 2I/Borisov, a large interstellar comet made of ices formed in another star system billions of years ago. It was bright, extremely fast, and already outgassing, meaning its frozen nucleus was vaporizing as it approached the sun, creating a glowing tail. But something didn't add up. Atlas was moving far faster than Borisov, and its approach angle didn't match any known interstellar drift patterns. While Oumuamua and Borisov arrived roughly in the direction of the local stellar stream, Atlas approached from high above the galactic plane, almost from the direction of the Milky Way's thick disk, a region populated by ancient stars and relics from the early galaxy. This meant Atlas could be older than our solar system, possibly older than Earth itself. That alone made it fascinating. But then came the data from Webb. The James Webb Telescope, operating in infrared, detected unusual thermal patterns around 3I Atlas. These weren't typical sublimation trails. The outgassing was inconsistent, concentrated on only one side of the comet, and the thermal signature was so asymmetric that it suggested the object had uneven structure, perhaps large fractures or cavities. This indicated an unstable nucleus, possibly one that had survived collisions or gravitational distortions during its journey through interstellar space. But the shock came when Webb observed something that defied expectations. Atlas was shedding mass far more rapidly than predicted. Comets do lose material as they heat up, but Atlas was losing mass at a rate 4 times higher than any modeled projection. And the outgassing was not symmetrical. It was chaotic, irregular, and coming in bursts, like jets firing at random. These jets create tiny thrusts, which can alter the path and speed of a comet. But they do not cause a controlled 300% speed reduction. They do not produce a long, smooth deceleration over millions of kilometers. Natural forces cannot do that. Yet something did. Data from NASA's Solar System Dynamics Group confirmed the slowdown. When Atlas first entered our detection range, it was moving at an extraordinary velocity, fast enough to fly through our solar system in a matter of months. But now its velocity had dropped to barely a third of that speed. According to the orbital models, Atlas should have been accelerating as it got closer to the sun. Instead, it was doing the opposite. The strangest part? The slowdown wasn't random. It was too smooth, too even. It looked controlled. Immediately, NASA performed risk assessments. Was Atlas on a collision course with something? Had it encountered dust, gas clouds, or gravitational forces we hadn't modeled? But none of the simulations fit the data. 3i Atlas is traveling through is extremely empty, far emptier than any region near Earth. It had nothing to run into, and a comet traveling at tens of kilometers per second cannot simply hit the brakes. So what was happening? That's when the European Space Agency and NASA jointly reviewed new imaging data. The side of Atlas facing away from the Sun had a massive structural depression, almost like a crater carved into the nucleus. But comets don't form craters like that in the cold vacuum of interstellar space. Something must have struck Atlas, and whatever hit it was powerful. Webb detected lingering chemical signatures around the fractured region, traces of ionized compounds that do not appear in natural cometary spectra. This indicated exposure to extreme heat or high-energy particles. Some researchers quietly proposed that Atlas may have passed through the remnants of a supernova shockwave or collided with debris accelerated by stellar explosions. If true, 3i Atlas might be carrying material forged in the death of a massive star. But the most disturbing theory came from several astrophysicists studying Webb's readings. They suggested Atlas may have been impacted by something artificial. The chemical signatures included traces of highly ionized metals, elements associated with refined alloys rather than natural cosmic dust. And among these traces were hints of structured particles, tiny metallic fragments that did not match the surrounding comet composition. If these readings are correct, Atlas may have collided with something manufactured, a probe, a spacecraft, or a fragment of an ancient interstellar machine. NASA has not confirmed this publicly, but internally the possibility has generated enormous attention. If Atlas truly collided with a derelict object drifting through space, the impact could explain its sudden slowdown. The collision would eject mass backward, reducing its momentum. But the scale of the slowdown still does not match a typical impact. It suggests something larger, or multiple impacts, or even an interaction with a massive field of debris. The problem is simple. We don't know what Atlas hit, and whatever it collided with is not in any known catalog. As it enters warmer regions, pressure buildup could destabilize the structure, slowing it through internal collapse. But Webb's data doesn't support rapid internal disintegration. The mass loss matches surface activity, not internal implosion. But if internal collapse isn't the answer, what is? The most controversial idea is that 3i Atlas is not entirely natural. Unlike Oumuamua, which was elongated and reflected light strangely, Atlas does look like a comet, but the slowdown, the chemical traces, the structured particles, and the controlled light deceleration suggest something interacting with it, something inside it, something attached to it, or something it passed through. One surprising possibility has emerged among a small group of astronomers. 3i Atlas might contain embedded metallic objects, pieces of something ancient that fused into the comet millions of years ago. Perhaps remnants of a destroyed civilization sucked into a forming star system, or fragments of an old interstellar craft that 3i Atlas picked up during its long journey through the galaxy. If these fragments heated unevenly, they could cause unusual outgassing patterns, and possibly even act like internal anchors slowing the comet. 3i Atlas remains the most mysterious interstellar object ever detected, and the coming months will determine whether it is simply an ancient comet or something far more extraordinary. If you enjoyed this exploration and want updates as NASA releases new information, don't forget to like, subscribe, and turn on notifications so you never miss the next discovery.